So in an auction bidding, the winner's curse is the phenomenon of the winning, or basically the highest bid price, being above the expected value of the item being auctioned. If you guys have ever been to auctions, yeah, many times, people buy things cheaper than they would on, if they were to go to the store. But then there's this thing that we call the winner's curse. People get excited. Some of them are get excited. Some of them are not experienced, and people just come over and end up buying at an auction, end up buying things at a higher price than they would if they were to go to the store. It happens, right? Because in auctions, people are the ones that set up the prices. So we're going to study the winner's curse. A study was conducted to see if less experienced bidders were more likely to be impacted by the curse than super excited experienced bidders. Right? Super experienced, but they get excited, right? Now the study showed that of the 176 bids by super experienced bidders, 21 bids were above the item's expected value. And of the bids by the 140 less experienced bidders, 37 winning bids were above the item's expected value. Okay, so for those that were super experienced, out of 176, 21 of them, or 21 purchases, were higher than store value. And for those less experienced, 37 out of 140 were higher than store value. Okay, so let's take a look. Find an estimate of P1, the true proportion of super experienced bidders who fell prey to the winner's curse. Okay, so from the super experienced bidders, so let me highlight here. Remember, I'm looking at super bidders, so I mean super experienced. I know 21 of them out of 176 purchases, 21 of them fell into the winner's curse. So I'm going to say my P1. The way I'm going to do this, I'm going to go 21 divided by 176. Now I want to do this on a calculator. I'm going to go 21. I'm not showing my calculator because you guys can do this easily. 21 divided by 176. I'm going to round it to 3 decimal places. I get 0.119. So I'm going to say my P1. As a matter of fact, let me even label it here. My P1 is 0.119. For my P2, it says find an estimate of the true proportion of less experienced bidders who fell prey to the winner's curse. Round to 3 decimal places as needed. Okay, so my P2 for the less experienced. So from the less experienced, I see there were 140 purchases, but 37 of them where they fall into the winner's curse. So for this one, my P2 value, I'm gonna go 37 divided by 140. I'm gonna type this on my calculator. I'm gonna round this to 3 decimal places. I'm gonna get 0.264. So you guys can do this on a calculator. Okay, now construct a 90% confidence interval for P1 hat minus P2 hat. Couple things that I need to know, okay? Couple things that I need to know. My P1, I'm not gonna look at this as a decimal, because if you guys went 21 divided by 176, you have a long decimal number, right? So I'm not gonna round it. I'm not gonna deal with decimals. I'm gonna deal with fractions. I'm gonna say 21 out of 176. That was my P1. So Q1 is gonna be 155 over 176. All right, so what I said is from the 176 purchase, my P1 is how many paid more than store value. And my Q1 is how many did not pay over store value. So the 155, I just went 176 minus 21. And then my N1 is 176 bidders, right? Now my P2, 37 out of 140 paid more than store value. My Q2 is going to be 103 over 140. And my N2 is 140. So what I'm saying is from the 140 purchases, 37 of them paid higher than store value. 103 of them did not. Okay. Now my confidence interval, I need a C-score here. My C-score is 1.645 for the 90% interval. How did I get this? Okay, I just went 0.90 divided by 2 gives me 0.45. I look for this on my C-score table, my probabilities. Right, it gives me a lot of percentages. I'm looking, where is this? Where it is 0.45. And it is in between 1.64 and 1.65. It is in between those. So what number it is right in between it? We'll add them up, 1.64 plus 1.65 divided by 2. And I happen to find is 1.645. Okay, so that's my C-score. Now, what's my formula? We've done this formula before. Let me give this to you. It's going to be P1 minus P2 because that's what I'm testing. I know here it says P1 hat, but it's the same thing as P1 plus or minus. And then my C-score. Then I'm going to have a square root of, and then inside I have a fraction plus another fraction. Now I'm going to do P1 times Q1 divided by N1. Then I'm going to do P2 times Q2 divided by N2. Okay. How am I going to do this, Mr. Leonzo? Follow me. Let's see. Let me bring my calculator. Let me clear this out. So I have this calculator. So you should have on your paper what's P1, Q1, N1, P2, Q2, N2, and what's your C-score and your formula. So based on our formula, it starts with a parentheses, P1 minus P2. So I'm just going to do 21 over 176. I'm going to click to the right so I get out of my fraction minus my P2 is 37 over 140. I click to the right so I get out of my fraction, close my parentheses. So notice I have my P1 minus P2. My calculator is working things out, but I'm not quite done yet. According to my formula, I have a plus or minus. So let me do my minus first. So minus my C-score is 1.645 times, I know I'm gonna do a square root, and then I know inside the square root I had a fraction. Let me get out of here. So plus another fraction. Make sure both fractions are inside the square root. Okay. So in the first one, remember I had P1 times Q1. So I'm gonna go 21 over 176. Let me click to the right times 155 over 176. All of this over 176. Let me click to my second fraction. I had P2 times Q2. So 37 divided by 140, I get out of this times 103 over 140. I do 103 divided by 140. The calculator recognizes a fraction, and all of this over 140. Boom. It gives me, let me round this to 3 decimal places, right? So I'm going to call this negative 0.218. So let me come here. My interval could be negative 0.218. Now let me go back to my calculator. I'm not going to have to type all this up. Remember, I just changed this minus to a plus. And it gives me negative 0.072. All right, I'm going to round up to a 2. So negative 0.072. There's my 90% confidence interval. Okay, let's take a look at another example. I'm going to flip the page. Let me take a look at here. School bullying is a form of aggressive behavior that occurs when a student is exposed repeatedly to negative actions from another student. It happens. School bullying happens, unfortunately. I wish it didn't happen, but it does happen. In order to study the effectiveness of an anti-bullying policy at elementary schools, a survey of over 2,000 elementary school children was conducted. So they asked 2,000 people. Nice. Each student was asked if he or she ever bullied another student. In a sample of 1,358 boys, 750 of them claimed they had never bullied another student. In a sample of 1,379 girls, 964 of them claimed they had never bullied another student. Okay, so here, give a point estimate for the proportion of boys who claim they have never bullied another student. Okay. Remember where I saw something about the boys? In a sample of 1,358 boys, 750 of them claim they had never bullied another student. And I'm working on, says give a point estimate for the proportion of boys who claim they have never bullied another student. Okay, so I'm gonna say 750 of them divided by 1,358. Right, 750 out of 1,358. Let me divide this because it's asking me to round this to the nearest thousandth. So I have to answer this as a decimal. And I'm going to say it happens to be about 0.552. Okay. I just went to a calculator and I went, all I did was 750 divided by 1,358, rounded to 3 decimal places, so 0.552. Now, give a point estimate for the proportion of girls who claim they had never bullied another student. Okay, 964 girls said they had never bullied, right? So 964 divided by 1,379 girls. So I'm just gonna grab my calculator and I'm gonna go 964 divided by 1,379. I'm gonna round this to 3 decimal places. So I'm gonna call this 0.699. So this is 0.699. Okay, I was rounding. So if I have to do confidence intervals, I'm not going to round on those. Now here it says, give a point estimate for the difference between the proportions of boys who claimed they had never bullied another student, and the girls who claimed they had never bullied another student. So basically here they're asking me what's P1 minus P2. In reality, I'm just gonna do this with my calculator. I'm gonna go 750 over 1,358 minus 964 divided by 1,379. Okay, let me bring my calculator. So remember, I'm just gonna go 750 divided by 1,358. I click to the right to get out of my fraction, and I go minus 964 over 1,379. According to my calculator, rounded to 3 decimal places, you guys can see it is negative 0.147. Okay, so let me come back here. It's a negative, oh no, it's up here, right? It's a negative 0.147 because it said to round it to the 3 decimal places. Okay, now construct a 95% confidence interval for the difference between the proportion of boys who had never bullied another student and the girls who had never bullied another student. Okay, so I need to find out some information here. My C-score. Remember, I'm gonna go 0.95, divide this by 2. So that gives me what, 0.475. I just went 0.95 divided by 2. So 0.475. Find in your C-score the one C value that gives you that percentage, and you're gonna find out that your C-score is 1.96. Okay, so for 95%, my C-score is 1.96. Now I know my P1, public success with the boys, I know 750 out of 1,358. So my probability of failure, right? So if 750 of the boys said they had never bullied, how many did actually bully? And in this case, it's going to be 608 over 1,358. You're wondering, how do I get the 608? Well, 1358 minus 750. Okay, and then I'm gonna say my N1 is 1,358. How many boys were there? Now for the girls, so P2, I know 964 of them did not bully. So probability of success, because I don't want people to be bullying. So 964 out of 1,379. So that means my probability of failure is 415 out of 1,379. How did I get 415? I just went 1,379. How many girls are there? Minus how many said that they did not bully. So that's how I get 415. And obviously my N2 is 1,379. And remember, what do I do for formulas? I've done this before, but let me give you guys our formula again. I'm gonna go P1 minus P2, my plus or minus my C-score. But my C-score, I multiply it by the square root. And inside the square root, I have two fractions. On the first one, I have P1 times Q1 divided by N1. And then P2 times Q2 divided by N2. Okay. So let's take a look at our calculator here. So it starts with parentheses, P1 minus P2. So 750 divided by 1358. Let me get out minus 964 divided by 1379, close parentheses. I have plus or minus on my formula, so let me use my minus. I know my C-score is 1.96, and then I have a square root. Inside the square root, I have a fraction plus another fraction. Make sure your fractions are inside the square root. Let me show you how it will not look inside the square root. See, that's not inside. So let me make sure you do stay inside the square root, okay? Okay, on my first fraction, I have P1 times Q1. So I'm gonna do 750 over 1358 times 608 divided by 1358. And at the bottom, I have 1358. Now, my second fraction, I have P2. Okay, so on the gross now, 964 divided by 1379, get out of that, times 415 divided by 1379. And my N2 is 1379. Okay, so you guys see my lower interval is going to be negative 0.183. Now for me to find the plus, let me erase that. Let me change that to a plus. And I'm going to call that negative 0.111. So let me come back to my table here. So I just found my intervals. Negative 0.183 and negative 0.111. I do highly recommend for you to get used to the calculator. Type in my question. Make sure you get the same answer, and then you should work on your homework.